Hey, hi, and welcome back. I hope that you are enjoying this training and you are learning something valuable. Okay, so now let's start with the part 4 of Introduction to Capacitor. So in previous video, we discussed two different purposes of capacitor. The first one was capacitor as an energy storage device, and the second one was capacitor as a filter. Okay, now in this video I will show you the practical demonstration of both the purposes. Okay, so first of all I will show you the practical demonstration of capacitor as an energy storage device, and later I will show you the practical demonstration of capacitor as a filter. Okay, so that's how we are going to cover this video, and I'm sure you will definitely enjoy this video. Okay, so now let's start with this video. So this is basically the same circuit that we discussed when we discussed the energy storage point. So I will put the image of this particular circuitry, and this is the 470 microfarad capacitor. Then this one is the 1 kilo ohm resistor, and in the end as a load this LED is connected. Okay, and I have powered this circuitry with an external lab bench power supply. So I have set the output of lab bench power supply to plus 10 volt. So this is basically the positive terminal of lab bench power supply, and this is the ground terminal of lab bench power supply. Okay, so we are powering this circuit with an external 10 volt. Okay, so I will show you the voltage of lab bench power supply on the multimeter in a moment. So first of all, let me switch on the lab bench power supply. So I have switched on the lab bench power supply, and you can see this LED is now switched on. So let me show you the voltage on the multimeter. So you can see the voltage on the multimeter, we are actually getting 10 volt. Okay, in the same way, this is basically the second circuitry. So just a second, let me zoom in. So this is the second circuit, and in this circuit, instead of connecting a 470 microfarad capacitor, I have connected a 1000 microfarad capacitor, and this circuitry is actually powered by the second channel of the lab bench power supply. So the lab bench power supply that I am using to power two circuitry is basically a dual channel lab bench power supply. So I can set the two different voltages on the independent two channels. Okay, so I have powered this particular circuitry with second channel, and that circuitry was powered with the first channel. But on the output side of both the channels, I have actually set the 10 volt. Okay. Now here actually the purpose to show you this demonstration is, here I want to show you that based on the capacitor value, it will be decided how much energy that particular capacitor is going to store. Okay, and we have already discussed every single thing from theoretical aspect in previous video. Here I am just going to show you the practical demonstration. Okay, so now let me zoom out. So I hope that the LEDs are properly visible to you. So what I will do, I will switch off the light, and later these LEDs will be properly visible on the camera. So let me switch off the lights. So I hope now the LEDs are properly visible on the camera. So I will now switch off the lab bench power supply, and after switching off the lab bench power supply, you will observe that this particular LED will switch off early, and after some duration this particular LED will get switched off. Okay, because we have connected two different values of capacitor. This one is 470 microfarad and this one is 1000 microfarad. Okay, so now I will switch off the lab bench power supply, and let's observe the change now. So you can see this LED switched off first, and later this LED switched off. Okay, so that's basically the demonstration for the energy storage of capacitor. Based on the capacitance of capacitor, it will be decided how much energy that particular capacitor is actually going to store. Now what I will do, I will actually increase the capacitance on this point. So I'm going to connect one more 1000 microfarad capacitor. So I will connect this 1000 microfarad capacitor in parallel to this 1000 microfarad capacitor. So I will quickly do that. Alright, so both the capacitors are now connected in parallel. So here on this side, on right hand side, we have a total capacitance of 2000 microfarad, and on left hand side we have a capacitance of 470 microfarad. Okay, now once both the circuitry or both the capacitors are charged, you will see that here the duration of discharge or this particular LED is actually going to take even more time to get switched off, because here the energy stored by these two capacitor is actually going to be more. Okay, so this time the energy is almost doubled. Now again I will switch on the lab bench power supply. Alright, so the capacitors are now charged. Now let me switch off the lab bench power supply and let's observe the change. So we saw that this particular LED took even more time to switch off. Okay, so this LED took the same time, but this time this particular LED took even more time. Okay, it's because of these two capacitors that we have connected in parallel. Okay, so that's what I wanted to tell about the energy storage point, and I hope that it's clear now. So based on the capacitor value, based on the capacitance, it will be decided how much energy that particular capacitor is going to store. Okay, so in the end I will just show you this demonstration one more time. So the capacitors are now charged, and now let me switch off the lab bench power supply. So you can see slowly this LED is discharging. Okay, so that was all about the energy storage point. Now let me show you the demonstration for capacitor as a filter. Alright, now let me show you the practical demonstration of how exactly capacitor is used to filter the noise or to filter the signal. Okay, so first of all, let me explain you this setup. Now in this setup you will see this particular board. It's actually a Arduino Mega board, and I have used this Arduino Mega board to generate a signal of 500 Hz. Okay, so I have programmed this Arduino Mega board to generate a signal of 500 Hz at this point, and I have connected this point on the breadboard at this point, and this is basically the ground terminal of this Arduino Mega board which I have connected here. And I have connected these two pins of this Arduino Mega board to the first channel of DSO so that we can see that 500 Hz signal. Okay, so now let me show you that 500 Hz signal on the DSO. So for that I will have to switch off the lights. So on the DSO you can see this is basically the signal with 500 Hz approx frequency, and this is how basically the signal look like that we have generated on this Arduino Mega board. Okay, now what I'm going to do, I'm going to show you how exactly capacitor filter out this particular frequency. Okay, 500 Hz frequency, and for that I have actually placed here some capacitor. This capacitor is of 104 which is 100 nanofarad. Then this one, the value of this capacitor is 100 microfarad, and after that this capacitor has got a value of 220 microfarad. Then this one is 470 microfarad, and after that 1000 microfarad capacitor. Okay, so here we will actually see which capacitor is basically suitable to filter out this 500 Hz frequency and which capacitor provides the lowest impedance path. Okay, so whichever capacitor will provide the lowest impedance path to this 500 Hz signal, that particular capacitor is actually going to filter out that this 500 Hz frequency. Okay, so I will start with this 100 nanofarad capacitor. So first of all, let me connect this 100 nanofarad capacitor between these two pins, the signal pin and the ground pin. And you can observe this signal on the DSO. So you can see on the DSO the signal is not filtered. Okay, and we are still getting a frequency of 500 Hz on the DSO. Okay, so you can observe this frequency here, 500 Hz. So it means that this particular capacitor is actually providing a very high impedance to this signal. So that's the reason this signal is not bypassed by this particular capacitor. When I explained you the impedance versus frequency plot of 100 nanofarad capacitor, I showed you that at 10 kilohertz, this particular capacitor was providing impedance of 200 ohms. Okay, now we are actually dealing with a frequency of 500 Hz. It means that this capacitor is actually going to provide even more impedance. Okay, even higher impedance. So I will put the image of impedance versus frequency plot for this particular capacitor, and you will see in that impedance versus frequency plot at 500 Hz what impedance this capacitor is actually providing. Okay, so this capacitor right now I think it's providing an impedance of around 1 or 1.5 kilo ohms. Okay, and that's the reason we are still getting that frequency on the output side, and which you can see on the DSO. So this actually tells us that this capacitor is not good at all at filtering this 500 hertz frequency. Okay, so I will remove this capacitor now. So I have removed this capacitor. Now let's connect this 100 microfarad capacitor. So I have connected this 100 microfarad capacitor, and on DSO you can see this. After connecting this capacitor, we are actually getting this kind of waveform. It's a kind of triangular waveform. So what exactly that means? Now this capacitor is actually providing a lower impedance path to this 500 hertz signal, but still the impedance provided by this particular capacitor is not in milliohms. Okay, it's in around ohms, let's say 50 ohms or somewhere around that. And how much impedance this particular capacitor is providing, in order to get that information, you need to refer the impedance versus frequency plot of this particular capacitor at 500 hertz frequency. Okay, so right now this capacitor is not providing the impedance in milliohms. That's the reason we are still getting the fluctuations on the output side. Okay, so this capacitor is not good at filtering this 500 hertz frequency completely. So again, I will remove this 100 microfarad capacitor, and let me keep this capacitor aside now. After that, now let's take this 220 microfarad capacitor. So I will connect this 220 microfarad capacitor here, and let's observe the DSO screen. And you can see on the DSO screen, this particular capacitor is actually again providing the same impedance which this 100 microfarad capacitor was providing. But this capacitor is providing little lower impedance compared to this one. That's the reason you can see on the DSO screen, the triangular wave or this ripples, actually they have got reduced. Okay, they have reduced by a certain amount. Okay, that's the reason. So again, this particular capacitor which has got a value of 220 microfarad is not good at filtering this frequency of 500 hertz. Okay, so again I will remove this capacitor now, and I will place it aside. After that, the next capacitor is 470 microfarad. So let's connect the 470 microfarad capacitor, and let's observe the signal on the DSO. So you can see on the DSO, this capacitor is actually, it has filtered out this frequency of 500 hertz. Not completely, still we are getting the fluctuations on the DSO screen, but still this 470 microfarad capacitor is actually filtering this 500 hertz frequency up to certain extent. Okay, so it means that this capacitor is providing lower impedance path to this 500 hertz frequency, but still the impedance provided by this capacitor is actually not in, so it's actually not in milliohms. Okay, that's the reason we are still getting some kind of fluctuations on the output side. If the impedance provided by this capacitor would be in milliohms, then this signal would have completely bypassed. Okay, so that was the 470 microfarad capacitor. Now let me place this capacitor aside, and after that, now let me connect this 1000 microfarad capacitor, and let's observe the waveform, what waveform we get on the DSO. So you can see again this capacitor is actually it has filtered out the 500 hertz signal, and which you can see on the DSO. Still we are getting some kind of fluctuations on the output side. This capacitor has not filtered out the there is actually not much difference in the 470 microfarad capacitor's output and 1000 microfarad capacitor's output. Okay, so 470 microfarad capacitor and 1000 microfarad capacitor had provided almost same impedance to this 500 hertz frequency. Okay, but still compared to 100 nanofarad capacitor, if we see this capacitor, these capacitor like 220 microfarad, 470 microfarad and 1000 microfarad capacitor has provided a lower impedance, and that's the reason these capacitor are actually able to filter out that particular frequency. Okay, so I hope that this point is now clear, how exactly capacitor filter outs the frequency or the noise. You can also consider this as a signal, or you can also consider this as an unwanted noise. Okay, so here my purpose was to show you how exactly capacitor filter outs the frequency or the noise from the from the line. Okay, so I hope that this point is now clear to you. Now I will remove this 1000 microfarad capacitor, and you can see on the DSO again we are getting the signal of 500 hertz frequency. Now here one important point on which I want to point out. Here actually we provided a signal with a 500 Hz frequency, and we observed that this 1000 microfarad capacitor was actually 1000 microfarad and this 470 microfarad capacitor, these two capacitors were actually good at filtering out this 500 Hz frequency. However, this 0.1 microfarad or 100 nanofarad capacitor was not good at filtering this 500 Hz frequency. It means what? It means that the observation is whenever you have to filter out the lower frequency, in that case, the value of capacitance, the value of capacitor that you have to use, it's going to be higher. So for 500 Hz frequency, we used 1000 microfarad capacitor. If you have to filter out, let's say 100 Hz, then in that case, you will need a capacitor with even higher value. Okay, so that's basically the point. And if you have to filter out the higher frequency, for example, in megahertz, in that case, we discussed that in impedance versus frequency plot of 100 nanofarad capacitor. 100 nanofarad capacitor provides lower impedance at a frequency of 10 megahertz or somewhere around that. So whenever you have to filter out the higher frequency, at that time you will have to go for lower values of capacitor, and whenever you have to filter out the lower value of frequency, at that time you have to go for the higher values of capacitor. Okay, so this is actually very important point, and this point is actually going to give you an idea what capacitor or what range of capacitor you should choose to filter out a certain frequency. Okay, so one important point, another important point that I want to tell you here is, you might have observed the audio amplifiers. In audio amplifier, the frequency is around 20 Hz to 20 kilohertz. Okay, that's the reason we need to use a bigger capacitor to filter out those frequency, and that's actually the reason why the size of audio amplifiers are actually bigger. Okay. However, in case of RF amplifier, if you see the size of RF amplifier are actually little, they are very compact. Okay, so in that case, we actually use a smaller value of capacitor like 100 nanofarad, or it actually depends on the frequency. So we go for the smaller value, and that's the reason those RF circuitries are little compact compared to the audio amplifier. Okay, RF amplifier circuitries are little compact compared to audio amplifier. Okay. So always remember, whenever you have to filter out the lower frequency, the value of capacitor is going to be higher and the size of capacitor is going to be higher. And whenever you have to filter out the higher frequency, in that case, the value of capacitor is going to be lower and the size of the capacitor, it's also going to be lower. Okay, so that's what I wanted to tell in this video. I hope that every single thing that we discussed in this video is now clear to you. And if you still have any kind of doubt, then definitely you can ask me and I will try to answer it as soon as possible. Alright, so that's what I wanted to tell in this video. Now I will see you in the next video, which is about Introduction to Capacitor Part 5. Okay, so I will see you in next video now.